Okay, so good morning to a total and everyone. We are from Group 5, Cluster 2. So today we are going to present our progress report, which is problem 3A. Yeah. So now I'm Wei Wang and I'm going to present about the top column, the broad diagram. So basically the top column is in the row 1 is basically is used to controlling the methanol composition in the distilled flow rate by manipulating the reverse flow. So easy to say that the manipulated variable that in this third column is the reverse flow rate, while the disturbance right is the distilled flow rate in the So you can see the block diagram here. So at the front there has a SD prime SPS, which is a set point. So this is a set point that we set, and then after that is we will send it to the GAN, which is a KM, as you can see. And then it will transfer all the signal to the GCS, which is a control valve. Control. And then the control right will send send the signal to the valve to send the valve, which is the RS. Sorry, send the signal to the valve from the P'(S) to the GVS. So the valve will proceed with the R'(S), which is the signal to the process. And then the process will produce a final control. The GPS is which is a final control element. And then which is produce an output is the SD'(S). And then while in the output right, there is a one is measured from this output, which is we call as a GMS, and then it's measure the output here, and then control the flow rate based on this one. And then there is a disturbance from the peak flow rate, as you can see at the top, which is F'(S) is a flow rate in the distillate flow rate, right? And then the GDS is a disturbance, no? So this is a disturbance point, and then this is a diagram from the block diagram. I think next I pass to Fatin.
Okay, to get the based on block diagram, we need to get the equation for each part, which is process, measurement, control mechanism, and final control element. So we will start with process equation. So you can see we have R prime S. We can substitute with final control element equation, and then the second part where P prime S, we substitute with control mechanism, and then same goes to S, we substitute with XD prime SPS minus XD prime MS. So to get this, we just need to multiply, and then we'll see 1S, 1 plus GPS, GCS, GMS, just as usual. And then that part we divide with the right side, and this part is several problem part, and the other one is regulated. So we can get XD prime S over SPS for the several problem, and then the other one XD prime S over F prime S for regulatory problem. And then I will pass to Jess.
Good morning, everyone. I am going to talk about bottom column. Okay, as you can see in the screen, the bottom column is loop 2. Methanol composition at the bottom column is controlled by manipulating the bottom flow rate, which means the bottom flow rate is the manipulating variable of this loop. As you can see the block diagram, the first it starts from the XB prime SP, which is the set point, and it sends a signal to the gain, which is steady state gain, and the signal comes out of that gain is that internal set point, which is then passed through a controller and then sent as error signal to the controller's transfer function. And after the controller transfer function, the controller output is sent as signal to the final control element. After that, B prime S, which is the bottom flow rate, which is the manipulated variable for this loop, is sent as signal to the process transfer function. And the GDS is the disturbance transfer function, which is the feed flow rate is the disturbance in this loop, which is sent to the disturbance transfer function, and the signal that comes out of the controller is that final bottom flow rate, which is XBS. And the final bottom flow rate is then taken to measured, which will become the final measured flow rate of the bottom flow, which is the XBS, which transfer to the measured measured transfer function. This is the block diagram for bottom column. Thank you. I will pass to Chai Hong.
So I'm Chai Hong. I will move forward to the transfer function of bottom column. So basically, when we want to derive the transfer function, first we need to first start with the process. So the process is this part. So it is influenced by the manipulated and also the disturbance. So this is how we write the equations. And from the B prime S, that is the bottom flow rate, we can derive using this one, using the control final control element, and moving on, and then you will get the P prime S, and you just substitute in what you have until you get the final equations of these. And for the front part, that is the solver problem, and the behind part, that is the regulatory problem. So basically, this is the final transfer functions, and this is the regulatory problem. Okay, that's all. Thank you.